Good afternoon. So we have seen different types of corrosion. So today let us discuss what are the factors affecting rate of corrosion. So there are various factors affecting rate of corrosion. Let us discuss in detail various factors affecting corrosion. The factors affecting rate of corrosion are relative areas of anode and cathode, that is cathodic area and anodic area, corrosion product, pH, temperature, conductivity. So let us discuss how these factors affect rate of corrosion one by one. To start with, relative areas of anode and cathode. Smaller the anodic area, larger the cathodic area, rate of corrosion is high. So if you have small cathodic area and larger, smaller anodic area and larger cathodic area, rate of corrosion is high. So why? Why any metal undergoes corrosion? So in order to, why anode undergoes corrosion? In order to meet the demand of electrons by larger cathodic area. So the demand of electrons by larger cathodic area can be only met only by anodic area by undergoing corrosion, right? So for instance, let us consider you have this is the what do you call, in the center this is small anodic area and this is cathodic area. So this cathodic area requires 100 electrons, okay, or 1000 electrons. So this demand can be met by this cathodic area only by anode by undergoing oxidation. So the metal undergoes oxidation to give you Mn plus and N electrons. So this N electrons, so instead of considering it as N, so let us consider we have zinc metal, okay. So we have zinc metal. So zinc undergoes oxidation. So Zn is anode. So Zn undergoes oxidation to give you Zn2 plus and 2 electrons. So as soon as the zinc liberates the electrons, the 2 electrons will be accepted by the larger cathodic area. Again, zinc will liberate 2 electrons, again it will be accepted. So what will happen? Zinc will be more prone to liberate more electrons. So because of this, what is happening? Zinc is undergoing more and more oxidation, and this is called as what? This is termed as corrosion. Okay, oxidation is termed as corrosion. Therefore, smaller anodic area, larger cathodic area, rate of corrosion is very high. So, for example, this type of case occurs in tinning. Okay, what is tinning? Depositing a layer of tin on the surface of iron or steel articles is called as tinning. So, the other case, so larger anodic area, smaller cathodic area. So, we have a metal. So in this is center part as cathode, okay. So cathode, and this entire thing is anode. So what is happening? So this can accommodate only 100 electrons, but from all the sides, what's happening? Electrons are coming, right? From all the sides electrons are coming. So let us assume even this case also zinc is anode. So Zn is undergoing oxidation to give you Zn2 plus 2 electrons, right? So unless the liberated electrons are accepted by the cathode, zinc will not liberate further electrons. So since the entire cathode is surrounded by anode, so as soon as zinc undergoes oxidation, the stomach of cathode will be filled. 100 electrons is filled. So next anode will further release electrons, but those electrons will not be accepted by cathode. Since these electrons are not accepted by cathode, zinc will not further release any electrons. So zinc is not releasing electrons, means this reaction is stopped. What is this reaction? Oxidation is stopped. So what do you call as oxidation? We term oxidation as corrosion. So corrosion is stopped. So rate of corrosion is less in case where larger anodic area and smaller cathodic area. So this occurs when this occurs in case of galvanization. Example for this is galvanization. What do you mean by galvanization? So galvanization is nothing but coating zinc on the surface of anode, coating zinc or depositing zinc on surface of iron or steel articles is called as galvanization. Next factor is nature of corrosion product. Any reaction that occurs in nature will produce a product. So A plus B gives C, right? So even corrosion occurs and it produces some product. So metal iron undergoes corrosion to give rust. Aluminum undergoes corrosion to give aluminum oxide, right? So metals undergoes corrosion to give the respect to oxides or sulfides or nitrides, isn't it? So even the product of corrosion is also have an impact on rate of corrosion. So how does it impact? Let us see. So if the corrosion product is highly soluble, porous and unstable, then rate of corrosion is very high. So the corrosion product is formed, it is highly soluble, so it is dipped in some aqueous solution. So as soon as the corrosion product is formed, it will dissolve in the solution, aqueous solution. So it is porous. So this is the metal, this is the corrosion product, it is porous. See, in these holes you can see the metal. Through this hole, the metal is in continuous contact with the surrounding corrosive media, and metal undergoes corrosion. And it's highly unstable. For example, if you take iron, so the corrosion product rust is formed, it will form, it will ooze out. It will form, it will ooze out. So here, every time the rust is oozing out, the fresh metal is exposed to the corrosive environment. Therefore, rate of corrosion is very high. So what are such type of metals? It is either zinc, magnesium, iron. So in such cases, we can see this. Okay, so there this type of corrosion product is formed. So in other case, if the corrosion product formed is highly insoluble, non-porous and stable, then what happens? So insoluble means it will form, it is not dissolving in any aqueous medium. So non-porous means, see, this is the metal, this is the corrosion product, can you see? No. And it is stable, it is sticking to the surface. So because of this, this corrosion product acts as a barrier between the metal and the surrounding media and protects the metal from further undergoing corrosion. So example, aluminium, nickel, chromium, tungsten, etc. So these are usually called as passive metals. So, okay, and nature itself has a given boon for these metals, aluminium, nickel, chromium, tungsten, etc., or aluminium like metals, to repair. So if aluminium, the coat is formed, if little it is ruptured, okay, it is ruptured, slowly it will heal and it will cover it. Okay, so like your iron or zinc or magnesium, you need not paint it. So nature itself is a given a boon for these aluminum and aluminum like metals to cure itself, okay, from corrosion. Next, pH. So pH, you know what is pH? It's a negative logarithm of H plus ion. So here the rate of corrosion depends upon the pH. So let us consider in acidic media rate of corrosion is high, and basic media rate of corrosion is less. So let us consider the example of iron. So iron undergoes severe corrosion in if pH is less than 3. So you know that, right? So when you take a metal and dip it in a strong acid, so it displaces hydrogen. So metal will dissolve. So if you take zinc and dip it in HCl, sulfuric acid, it will dissolve, displacing hydrogen. So if the pH is between 3 and 7, 3 and 10, so oxygen is very essential for the metal to undergo corrosion. If pH is above 10, so the pH is above 10, so what happens? If pH is above 10, the rate of corrosion is very less. So why? Because so pH is above 10, it is a basic media. So at anode, what is happening? At anode, let us consider iron as example. So iron undergoes oxidation to liberate Fe2 plus and 2 electrons. Okay, this Fe2 plus will react with OH minus ions and it forms ferrous hydroxide. Okay, so this ferrous hydroxide covers anode and acts as a protective shield, thereby preventing metal from further undergoing corrosion. It is not that it will completely stop, but rate of corrosion is less. Okay, so this is how the pH also will be affected. So if you take temperature, so temperature is directly proportional to, rate of corrosion is directly proportional to temperature. So as the temperature increases, rate of corrosion also will increase. Why? Because as temperature increases, the conductivity also will increase. As temperature increases, the conductance of the medium also will increase. The conductance and temperature are directly proportional to each other, isn't it? As temperature increases, the conductance also will increase, therefore rate of corrosion also will increase. So you can see in few of the few instruments, only moderate temperature up to 60 degrees it will be maintained. So if it crosses, what will happen? The entire instrument will corrode. Okay. So conductivity. So conductivity, once again, conductor rate of corrosion and conductance are once again directly proportional to each other. So if you take a metal, dip it in normal water, and take a same metal and dip it in marine water, you can see the rate. Iron undergoes severe corrosion, which is in, if it takes iron itself and dip it in normal potable water, drinking water, and dip it in sea water, that is marine water, you can see which metal undergoes severe corrosion. The metal is dipped in marine water undergoes more corrosion than the water which is than the metal is dipped in normal drinking water. Why? Because the water, whatever we call, it is not a solvent, it is a solution, marine water, because it contains soluble salts, sodium chloride or magnesium chloride, magnesium sulfide. It contains soluble salts. Since it contains ions, the conductivity of this is high. So the corrosive is, since it's an electrochemical phenomenon, so which involves transfer of electrons. So what happens? This will, the ions will influence the rate of corrosion. So the conductive species, whatever it is, sodium Na plus ions or Cl minus ions or Mg2 plus ions, these conductive species present will increase the rate of corrosion. So rate of corrosion increases is directly proportional to conductivity. Okay, so these are the factors which affect the rate of corrosion. Thank you.